So now that we know what this f composed with g is for this particular problem, there are many different things that we can ask about f composed with g. So for part B, the question is, find the domain of that function f composed with g. Now, remember once again from our definition, f composed with g of x is f of g of x. And using the ideas we talked about in part A, you start on the inside and you work your way out. So the very first thing that you have to evaluate when you do f of g of x is g of x. So if you're looking at an x value that doesn't make sense for the function g, immediately you have to exclude that, because that won't work in this f composed with g world if it doesn't even work in the g world. So you'll notice over on the right hand side, I've written out some statements here. So whenever you're trying to find the domain of a composite function, the first thing you want to think about is you need to exclude any x value that are not in the domain of g. If they're not in the domain of g, there's no way that the composition is going to make sense. So now that we have that item number 1, well, what happens then next? I have to take whatever I find for g of x and I plug that into the function f. So when I look at this whole thing, it's not that I'm interested in x values that cause me problems for f. It's interesting in terms of what my g of x values are that could cause me problems for f. So for step number 2 then, I have to be careful about any x values for which g of x is not in the domain of f. So now that we have those ideas then, let's go ahead and check out the domain of f composed with g for this particular problem. So as we look at step 1, it's all about our function g. So I'm going to go back up to our directions. G of x is equal to 3x minus 1. Remember, when you think about the domain, there are 2 things you have to consider. You can't take the square root of a negative number, and you can't divide by 0. Well, as I look at this g of x, neither one of those things is happening. I'm not taking any square roots, I'm not dividing by 0, so the domain of g is all real numbers. So I don't have to worry about anything for item number 1 here, because there are no x values that are not in the domain of g. Well, okay, the next thing then that I have to think about is what's happening with the domain of f. So I'm going to go back here to my f guy. F of x is equal to x squared. Again, no square roots, no division by 0, so the domain of f is all real numbers as well. So for step number 2, I have to be concerned about any g of x values that are not in the domain of f. Everybody's in the domain of f, so 2 isn't going to cause me any problems either. So item number 1, I'm not excluding anybody because I'm not going to have anybody that's causing me problems with the domain of g. And item number 2, I'm not excluding anybody there because I don't have anybody that's causing me problems with f. So the domain of f composed with g on this particular problem is still all real numbers. Now, as you look at this particular problem, this doesn't feel fully satisfying at this point, because this particular problem, the f and the g are so easy that the domains end up being simple as well. So in a moment, we'll check out another example, and we'll see what happens if your f and g are a little bit more interesting.